The invisible hand, spontaneous order, the market economy adjusting. These are the amazing things that the macroeconomists that we call classical macroeconomists really focused on. The idea that the price system adjusts our macroeconomy back to our potential output, back to our long run aggregate supply curve if we're using our aggregate supply, aggregate demand graph. It's all about the price system adjusting the macroeconomy. But what if we mess with that price system? A lot of modern macroeconomic ideas are going to put a very large emphasis on monetary policy if we change the money supply around. So, how do we think about classical macroeconomy when we're talking about the money supply changing? That's what we're going to talk about here. So, we're going to say, hey, money is one half of all transactions. And so, if we mess with that money supply, what happens? Can we still see the miracle of the price system adjusting? Are classical economists saying, yeah, the economy adjusts really well as long as we get monetary policy perfect and we don't touch it? Turns out it's going to be no. We're going to have a similar kind of story about how the market process adjusts even when we mess or tamper with the money supply. So, in order to appreciate the classical economist's take on how money impacts the economy, we're going to develop some tools. We'll talk about the equation of exchange, the quantity theory of money, and we'll tie these in to the classical view of macroeconomics. There really are a couple of different versions of the equation of exchange, and we'll start by introducing what we call the transaction approach to the equation of exchange, and we'll build that into kind of the more traditional approach to the equation of exchange. But here's the basics of the equation of exchange. MV equals P times, and in this case, T transactions, since we're doing the transaction approach. Now, what do these variables actually stand for here? That's what we're going to talk about as we introduce this topic. So M is our money supply. So this is our money supply as measured by, say, M1 or whatever your metric of choice is here. But we're thinking about how much money is in the economy. What's our money supply that we have here? Up next is our velocity, or our velocity of transactions that take place in the economy. This is the velocity with which money goes through the economy. It's the average number of times that a dollar enters a transaction, that engages into a transaction. So it's how quickly is money circulating through the economy. That's what we're looking at there with velocity. This is going to be kind of the toughest variable, and we'll show this as we move throughout what velocity actually means as we keep moving. And then P is our price level, right? And our price level, or our overall kind of net of our transactions in this case. So we're looking at the price level that is represented by the GDP deflator or CPI, however we're measuring these things, but the concept of price levels in there. And then this T in this case is just simply the number of transactions that occurs within our economy, right? And as I said, this kind of makes more sense as we actually go through an example. So that's what we'll do next, is we will use the transaction approach of the equation of exchange to try and lead us into our understanding of the kind of standard representation of the equation of exchange. So our example is going to start with two individuals each having $2 bills. So this person has two, this person has two, right? And so each person has $2 bills. Our overall amount of money in the economy is just $4. We only have two people who are there. And we're imagining this world where we have two people and they both have some water bottles that they're going to exchange with one another. That's their production. And we say, okay, they have these water bottles. We're not really worried about how many they produce or anything like that, but they have some water bottles, right? And so what we're going to say happens is that one person takes $1 and pays the second person for a water bottle. And then the other person, right, that happens, is going to buy a different water bottle from the other person. Okay, and so what we have is each person has bought a water bottle from the other person. And what we're going to say is that each water bottle, well, it cost just $1, right? So just one of those got transferred over here to the other person. And then also in our economy, we can imagine that this person sent a dollar over here to purchase a water bottle from them, right? So that is our setup for the economy, right? What do we have here then in terms of the equation of exchange? Well, our first variable is M. That's the money supply. That's the total amount of money that is in this economy. Well, we have 1, 2, 3, 4 dollar bills, right? So our total amount of money in the economy is 4. V, velocity, that's going to be the tough one. So we're going to save that one for the end, but we'll think about what that actually means as we go through. Then we have P, the price level, the average level of prices. Well, each water bottle, we said, it was purchased at a price of $1. So the average level of goods, the prices of goods, or the price level in our economy is $1, right? To make an exchange, the first one, it cost $1. The second one, well, it cost $1 also. And so the price level is just 1 here. And then the last thing we can look at is T, the number of transactions that took place. Well, this person bought a water bottle. That's 1 transaction that took place. And then this person bought a water bottle. That's 2 transactions that took place. So the total number of transactions that took place is 2, right? And so now we can go through, and if we don't really know what V is representing here, we could still solve for this because we know that M times V is equal to P times T. And so we have 4 times V is equal to 1 times 2. And so what we have is 4V is equal to 2, or V is equal to 1/2. Okay, so we solve for that. We say, okay, V is equal to 1/2. That's fine. What does that actually mean? What's V equals 1/2 actually representing? Well, this means that the average dollar bill changed hands an average of 0.5 times, or 1/2 times. So if we looked at it, this dollar bill, this was purchasing something, right? It went down and purchased something. This dollar bill, it didn't do anything, right? It never was actually used in an exchange. The first dollar bill, yep, it was used, and it was used 1 time. Then we can look at the third dollar bill and we can say, oh, this one was used, the one that was used to purchase something from the other person. So this dollar bill, yes, it was used, and it was used 1 time. Whereas again, this last dollar bill, it wasn't used to make a purchase, and so it didn't get used. So what is the average number of times that a dollar bill was used? Well, we have this one was used once, this one was used 0 times, and this one was used 0 times, and this one was used once. And so we have 1, 0, 1, and 0. The average of those 4 is 1/2. That's our velocity, the average number of times that this dollar bill exchanges hands here, right? The average number of times that a dollar enters income for new stuff, the average number of times that this money is actually being used, all right? So we can clear this off and we can say, okay, well, that's nice, it worked out there, but let's look at another example to try and clarify these terms. So if we have another example, we say, okay, there's $4 in the economy again, and we're going to say, once again, each person has 2 of these dollars. So in our second example, though, what we're going to say is that, okay, a person is going to buy a water bottle from the other person, right? So person 1 up here at the top is going to buy a water bottle from the person down below, but this time it costs $2 to make that purchase, right? So we have to send both of those dollars down to the low person in order to purchase this water bottle, right? So we use both of those. And then what happens is, oh, well, the other person buys a water bottle, this time also for $2. So they have to take $2 and send it up here to person 1 in order to buy a different type of water bottle. So basically they're making specialized versions of water bottles and then exchanging them to the other person, right? So weird economy, but nonetheless, this is what happens. All right, so in that setup, right, what did we have happen here? Well, we can look at it once again and we can say, what was the money supply? Well, there's $4 in the economy, so it's 4. Our price level this time, the average cost of the goods that were sold, is 2. How many transactions took place? Well, once again, they bought 1 and then they bought 1. That's 2 total transactions though, so we have 2 here. So what is the velocity? Well, MV equals PT. And so we have 4 times V is equal to 2 times 2. So 4V equals 4. So V should end up equaling 1. That's our velocity, right? What does velocity mean? It's the average number of times that that dollar bill cycles through the economy. Well, if you look at it, if we look back, both of these dollar bills were used in the first transaction. They were both used once. And then in the second transaction, both of these dollar bills were used, and they were both used once. So the first dollar bill was used once, second dollar bill used once, third dollar bill used once, fourth dollar bill used once. What's the average number of times that a dollar bill was used? Well, it's 1. And so we can see here that this relationship, this MV equals P times T, it is true by the way that we define our variables here. So this equation of exchange, it is true by definition, and it can help us understand what the other variables actually represent. So if you can understand 3 of the variables, you can solve for that last variable, as we did here with velocity, which is usually the variable that most students have a little bit of a hard time understanding at first. But this equation of exchange, it is everywhere true because it is true by definition. Let's do one more example to test to see if you understand the equation of exchange and these relationships here. All right, so here's the setup of the problem. What you're going to do is you're going to look at this problem, pause the video, and then see if you can solve. In our economy, there's only pizza that is being sold, and we're producing 100 pizzas every year. And what we're going to say is that pizza sells for $10. So each pizza sells for $10, and there's 50 total dollars in the economy. So if 100 pizzas are produced and sold every year, and they sell for $10, and there's 50 total dollars in the economy, what is the transaction velocity of money in this sample problem? So here is the answer to your equation of exchange pizza problem. We can start off by noting that M is the money supply. How much money was in this economy? We said there is $50 in this economy. Then we can look and we can say, okay, well, what was the price level? Well, every pizza sold for $10. So we're going to put 10 as our price level. And then we said that T, the number of transactions, was 100. There were 100 pizzas that were produced and sold in this economy. And then the question became, well, what's V then, right? And so that's what we want to turn to next. What is V in this economy given that basic setup? And so what we will see is we can get to an equation where we have M being 50, P being 10, and T being 100, and we can create this outcome where we have filled in with the equation of exchange, MV equals PT. And then it's just basic algebra to solve for V, and you end up with V equal to 20. So hopefully you got that question right, and you understand the basics of the equation of exchange. It's really easy to do with the transaction approach. But now what we're going to do is we're going to kind of convert this into the standard approach to the equation of exchange. So here we're moving from the equation of exchange that uses transactions to the standard approach where we use output. So we're using the output equation of exchange. You can see that this is basically exactly the same. This is what you're going to see in your textbooks. This is the normal way. We just do the equation of exchange with transactions to kind of make sense of what the variables are. And then we use it with the output approach here. So here we have MV is equal to PY, or output, instead of the number of transactions. M is still your money supply. V is now the velocity of income, how much that income is circulating through the economy. P is still your price level. And now we just have Y is your measure of output in the economy. So how much real GDP do we have, right? So Y is our real GDP, our output in this version of the equation of exchange. It's important to understand that the equation of exchange, it's true by definition. MV is identical to PY in terms of the mathematical expression here. So this is true by definition. It's by the way that we define these variables. MV is equal to Py. Because what we're turning to next is in line with what classical macro had to say. We're building a theory, the quantity theory of money. And the quantity theory of money says that in the long run, changes in the money supply are just end up being changes in the price level. So the quantity theory of money, this theory that we're going to build off of the equation of exchange, is showcasing this neutrality of money. There's just two assumptions that are needed for the quantity theory of money. The idea that V, velocity, is relatively stable, and so we can hold that constant. And that Y, our output, or real GDP, is also relatively stable, and so we hold that constant as well. If you assume V is constant, we have to ask the question, is that a reasonable thing to do? Should we assume that V is constant? Well, this is probably a reasonable assumption. The equilibrium level of velocity is probably fixed somewhat by institutional factors that don't change very quickly. At times, velocity might ebb and flow with consumer confidence, but it's somewhat reasonable to assume that V is held fairly constant. And since Y is real output or real GDP, this is determined by factors of production. In the long run, we know that this must be fairly fixed. We look at the solo growth model, or the idea that the long run aggregate supply curve in our aggregate supply aggregate demand model is vertical. And so when we hold Y and V constant, what we see is just that any increase in M just translates into an increase in P. An increase in the money supply, in other words, changes proportionally with P. And what we see is just inflation if we increase the money supply. You add money into the economy, you get inflation, but no real changes to output. So if we increase the money supply, we get rising prices. This is what the quantity theory of money says for us within basic classical macroeconomics. The idea here is that the price system adjusts our entire economy so that changes in the money supply, they don't end up being a really large factor. This is, of course, other than extreme examples where we have hyperinflation or things like that. So the equation of exchange gets turned into the quantity theory of money, which the classical macroeconomists use this as a basic idea for how money impacts the economy. V is held stable and Y is held stable to give us that quantity theory of money. This theory holds in the long run. Almost all economists now basically agree with the quantity theory of money that is built off of the equation of exchange, but they agree with it in the long run. What's different about the classical economists is that they felt like, well, the long run, it doesn't take us that long to get there. So why does this matter for us? We can represent the classicals as feeling that the long run wasn't so far away. They felt that the price system adjusted and adapted fairly quickly to get our macroeconomy back on track, that money would be somewhat neutral in the long run. The money supply only impacts the price level, and people adjust to changes in those price levels. In other words, adjustment of the price system, the move to our long run, it's not perfect, but it's a relatively smooth and quick process. We don't have to worry so much about the monetary side of our economy. Our markets and individuals adjust. Money is neutral in the long run. If we double the money supply, prices just double. The market adjusts. This is kind of the song of classical macroeconomics. All right, so that was the classical macro quantity theory of money. To see how that really combines together to give us an overall picture of macro with the self-corrective mechanism, click on the video to continue on in our lecture series.